Dear ladies and gentlemen, first of all, I thank the organizers of the conference for the opportunity to present a scientific report, Mixed Integer Linear Programming Formulation of the Unit Commitment Problem with Boundary Conditions on the Autonomous Forecasting Horizon. My name is Sergii Saukh. I am Doctor of Technical Sciences, Professor, corresponding member of the National Academy of Sciences of Ukraine, the head of the Department of Mathematical and Econometric Modeling of the Puho Institute for Modeling and Energy Engineering of the National Academy of Sciences of Ukraine. In the conditions of the development of green generation, the development of mathematical models of electric power system is an actual research. The uncontrollability and variability of electricity production volumes by generators of wind and solar power plants is constantly increasing. As a result, the load regimes of power units operating according to the traditional generation technologies are significantly changing. Therefore, in order to achieve the adequacy of models of electric power systems, it is necessary to use representative weekly intervals of mode forecasting instead of traditional daily intervals. And load modes of power units should be described in the form of unit commitment problems, which is a problem of mixed integer linear programming. In the unit commitment problem, operating costs for electricity production are minimized, including cost for start-up, shutdown power units. Usually, solving the unit commitment problem allows you to determine the evolution of the power system loading mode startup from its known current loading mode, the initial mode. Such short-term forecasting of power system loading modes is carried out by dispatch management services. Long-term planning of the development of electric power systems using unit commitment problems for modeling the evolution of power unit loading modes is problematic due to the unknown initial power unit loading modes. Today, initial regimes are set a priori without any justification, which significantly reduce the adequacy of predictive solutions. To solve the problem of applying unit commitment problems in the tasks of long-term planning of the development of electric power system, the transformation of unit commitment problems with initial conditions into unit commitment problems with boundary conditions is proposed. At the same time, the boundary conditions ensure the cyclicity of solutions of unit commitment problems, which allows extending the weekly loading regimes of electric power systems to seasonal periods, which they represent in long-term planning problems. Now, how to make the transformation from unit commitment problems, transition from unit commitment problems with initial conditions to unit commitment problems with boundary conditions will be shown on the example of a fairly common formulation of such problems in the form of an objective function 1a This is the sum of generation costs as well as the implementation of power unit shutdown, startup operations, and the group of restrictions which remain unchanged and are represented on this slide, namely balance equation of electricity production and consumption volumes, 1b. Limitation on the required level of rotational power reserve, 1s. Upper limitation on the load level of power units with the duration of startup periods of less than 1 hour, taking into account the maximum achievable load during the startup period, 1D. A ratio between the load level of power units and its initial values, 1I, 1G. The ratio between the accepted and potentially achievable load levels of solar power plants and wind power plants generators. Obviously, all the ratios presented here do not require transformation. Now let's turn to the upper limit of the load level of power units with the duration of startup periods of less than 1 hour, taking into account the maximum achievable load of these units during the shutdown period 1E. The transformed view on the constraint is shown at the bottom of the side, 10AB. Here, red dashes highlight the variable argument of the functions, and green dashes highlight the scope of the argument for the generated constraints that operate on the cycle time period. In the same way, we carry out the transformation of the upper limit of the load level of power units with the duration of startup periods of more than 1 hour, taking into account the maximum achievable load of this unit during the startup shutdown periods, 1F in 11AB. Transformation of speed limits for increasing and decreasing the load level of power units, 1G and 1H, into 12AB and 30AB respectively. Transformation of the balance equation of startup, load, shutdown states of power units, 1K into 14AB. The transformation of restrictions that are taken into account the low limit of the duration of the startup state of power units, 1L into 15AB. The transformation of the restriction that take into account the low limit of the duration of the shutdown state of the power units, 1M into 16AB. The transformation of restrictions that determine the level of startup cost of the power that, depending on the length of the period that has passed since its shutdown, 1N into 17AB. Unit commitment problem of modeling loading modes of power units with initial and boundary conditions were used in planning the development of generating capacities of the regional power system with the generating capacities of solar, wind power, and nuclear power plants with small model reactors of the NuScale company. The results of computational experiments demonstrate a significant influence of the initial conditions on the load mode of the power units and, as a result, on an adequate assessment of the efficiency of using power of the installed power units. As a result of the conducted researches, the following conclusion can be made. We have proposed a new mixed integer linear programming formulation of the unit commitment problem with boundary conditions, which is intended for application of autonomous weekly periods. The proposed formulation of the problem ensures the adequacy of optimization solutions in modern conditions of significant penetration of electricity production technologies from renewable energy resources and increased requirements for maneuverability and flexibility of electric power systems. Thank you for attention.